Okay, great. All right, so this is what Stata looks like when you have it open. And you open it like any other program, just click on it. And so this actually, I think there's a slightly updated version in the lab, so the colors might be different, but it's basically going to look the same no matter what version you're looking at. And the middle part, this big window in the middle, is where you're going to see your output based on the commands you give. And then you can always adjust the size of these windows by going to the edge of each window and just dragging. So the bottom window where it says command, that's the command window where you're going to enter the commands. And I don't have any data sets open right now, but once I open the data set, you're going to see the variables in this top right window where it says variables. And in most of the data sets I'll be giving you, it'll have the variable name as well as a description of what that variable is. This bottom right screen where it says properties is more technical aspects of the variables, storage types, and so on. I don't usually need that window, but you can always make it smaller if you want, but we don't have to pay it too much attention right now. And then on the left side where it says review, this is going to give you a running history of the commands you have given to Stata in any given session. So this can come in helpful, we'll see, when you just want to redo some commands that you did like a few minutes ago. You just can go back to the review and click on those commands, and those will then appear in the command window and you can re-execute them without having to retype the command over. Okay, so once you have it open, you can open the data set and start your log file. So it doesn't really matter which order you do it in, but I always recommend you start your log file first, just because then you'll know which data set you're using. If you happen to forget which one you opened, if you have the log file open, it'll have in there which data set you opened. So I'm going to go ahead and start my log file first. And I just go to File, Log, File, Log, Begin. And again, this is just going to keep a record of everything you do. So when you go to File, Log, Begin, it's going to ask you to save it somewhere on your hard drive. And before you save it, what I want you to do, and sometimes this is hard to remember the first couple times you do it, I want you to change the format. So right now, it's in what's called an SMCL format, and this is proprietary to Stata. The annoying thing about SMCL format is that when you try to open it in a word processor, it looks weird. So we're going to go to the drop down and choose the next format, which is .log. So that's why we call it the log file. It'll have a .log extension. And then just name it whatever you... Oh, yeah.
I don't think my screen is updating because I don't see like all the drop downs and stuff.
What do you see right now?
I just see like this main screen, like it says data, statistics, data analysis, the license to you and all that kind of stuff.
Oh, okay. Well, that's not good. I'm sorry. Did you try refreshing just to see if that helps?
All right, I'll do that real quick.
Yeah, I'm getting
Brady,
the same thing.
Brady, you can't see like a window that opened?
No, I think drop downs typically don't show up in recordings.
Oh, you know what? Let me just, instead of sharing, because right now I'm sharing an application, I'm just going to share my whole screen and that might work. So let me just try that. Give me one moment. I know that should look weird for a second if you see like a cascading thing. So now I'm going to go back to Stata. Okay, can you see Stata again?
Yeah.
Okay, now let me try this again. I go to File.
It's working now.
Log Begin. Okay, good. Sorry, my bad. Okay, so now we went to File, Log, Begin. So now we have the drop down where it says, you see where it says SMCL? Where you want to choose .log, which is the second option. Can you see that?
Yeah.
Okay. Okay, cool. So you'll choose .log and then you'll just name it something. So I'll just call this warm up and then just save it. Just remember where you put it because you're going to go back to it later to open it in Word. So I'm just going to put it in a different folder because I don't know why I will not remember that it's here. Let's see, econometrics class, warmup.log, save. Oh, I already have one. So let me, I'm just going to cancel and rename it something else. So I'm going to do that again. File log begin .log warm up. Okay, there we go. So now it tells you that you opened a log file and what time you opened it and where you put it and so on. So if you do forget where you put it, you can come back and check. All right, so now I'm going to open my data set. And so you can go to File Open, or you can actually open a data set just by clicking on it, but then you won't have the log file open already, so you won't know which data set is open. So the safest thing is to open Stata, create the log file, and then go to File Open and find your data set. So you're going to have it somewhere on your hard drive. And I'm going to find mine under Stata Warmup. And the one I'm using is called apple.dta. So I just click on that. And then it says, okay, this is the data set I'm using, and it says where it is. And then you'll notice that on the right-hand side in the variables window, all the variable names popped up, and there are descriptions for them as well. So we have education, years of schooling. We have reg price is going to be the price of regular apples, and eco price is going to be the price of the organic apples. We're going to use household size. This is a variable called male. That's equal to 1 if the person interviewed was male, and then 0 if they're not. Family income measured in thousands of dollars. Age of the person answering the questions. Regular pounds would be the quantity they said they would buy of the regular apples in pounds, and then eco pounds, the quantity of organic apples in pounds. And there's some other variables in there. Okay, so I have the Stata warmup document right next to me, so I'm not going to go back and forth. I'm just going to keep Stata up as much as possible and read over the warmup exercise. So you can always open that if you don't have it open. Do you guys have that next to you or open?
You said it's on Blackboard?
Yeah, it's on Blackboard under Stata warmup.
Okay.
It's just the first document.
Okay, I have it open.
Okay. All right, so we already did one. We opened Stata and we created our log file, and we already opened our data set. So just one other thing I wanted to point out is that you can look at the data set and if you want to check something, and the way to do that is to go to data at the top and then data editor, and then you can either choose edit or browse. And I always recommend you choose browse because it won't allow you to make changes to your data if you choose browse. And we really don't want to make changes to our data this way because we wouldn't have a record of it. You always want to have a record of the changes you make. So if you go to data editor browse, it'll pull up the data set itself in spreadsheet format. And you can see the variable names across the top. And then each row represents one of the households. And so you can always look at it, and when you're done, you can scroll at the bottom and just see how many variables, what they are, blah, blah, blah. When you're done looking at it, you can just close out of it. Right now, we don't really need to look at it for any particular reason. I just wanted to show you how. So the other thing I wanted to mention is that you can make notes to yourself in Stata that Stata will not recognize as commands. And the way to do that is to put an asterisk in the command window. So I'm putting an asterisk, and then I'm going to put question 3. So this is just if you want to label a question number or make a quick note to yourself, you can do that, and Stata will not recognize that as a command. That will just show up in the log file.
Can you put comments in the middle of a command?
No, not that I know of. Actually, I've never looked that up, but I don't think you can.
Okay.
I've never tried. So, but you can try and see, or we can look that up. So number 3 says use the describe command. So we'll see what describe tells us. It's not that exciting, but it will just pop up a few characteristics about these various variables. So I'm just going to enter describe in the command window, followed by the variable names I'm interested in. And there's 2 ways to get the variable names in the command window. You can either type out the variable names, or you can go to the variable window and click. So for example, I want to know about education. I'm going to come over to the variable window. You have to double click, and education will pop up in the command window down here. Or you can just type education, and you want to put a space in between the variable names. So we want to look at education, in season, household size, age, male, family income, the prices, regular price, eco price, and then the pounds, regular pounds, eco pounds. So I have describe followed by my variable names, and then I'm going to hit enter. And this is my output. So all it's telling me is the storage type, which we're not concerned about, that's technical, the display format, the variable label. So this is giving us the description of the variable. So years of schooling, in season is equal to 1 if they were interviewed in November. Family income is already measured in thousands, etc. But this is the same thing that's already in the variable window. So it's not really, terribly exciting. Inspect on number 4. So I'm going to add an asterisk and put question 4. So I want to inspect those same, well, I said use the inspect command to learn more about the following variables. So I'm just going to type inspect followed by education and male. Hit enter. And it's giving me some kind of weird looking output, but it's giving me output for both education and the demi variable called male. So if you look at the top here, it says education years of schooling. It has this ugly graph, and it says there are 12 unique values for the variable education. And it's telling you that the minimum is 8 and the maximum is 20. So people in the data set range in terms of years of education from 8 to 20. And then over here, it's telling us the number of observations that are positive, negative, 0, missing, and not missing. So for education, there are no negative values. There are no 0 values. They're all positive, which makes sense because we expect years of education to be positive. And we have no missing data. There's a little dash there. So we have 660 people. Everyone has a value, a positive value for years of education. If we look at the variable male, it's either 0 or 1. It's telling you it takes on 2 unique values, which we already know. There are 487 0 values and 173 positive values, which means those are equal to 1. So we already know that that means there's 173 men in the data set, and the rest are women, and there's no missing values. Okay, any questions so far? Okay. All right, so now we can move on to some slightly more interesting commands. Number 5 is summarize command. You can do a lot with the summarize command. So I'm just going to first just summarize the following variables. What I'm going to do, since these are basically referring to the same variables as number 3, I'm going to show you how to use the review window. So if you look at the left-hand side window where it says review, you can click on the describe command we gave earlier, and that will appear in your command window. Now, we don't want to describe these variables again, but if we did, we would hit enter. We want to summarize them. So I'm just going to replace describe with summarize. And in fact, you really only have to type sum because that's the shortcut or abbreviation for summarize in Stata. So sum followed by all these variable names. So this is what the basic summarize command gives you: the variable names, the number of observations, the mean for each variable. So the average years of education is just over 14, the standard deviation, and then the minimum and the maximum values that each variable takes on. So I just have a few questions under number 5 that we can answer. We already know A says how many people were interviewed. We already know it's 660. B, we already know. It says what is the minimum and maximum years of education? That goes from 8 to 20. C says what percentage of the people interviewed were male? So for that one, if you look at the male variable, which is the 4th one down, the mean value is 0.262. So since it's averaging over zeros and ones, that tells you the fraction of the population that's male. So we know that in the sample, just over 26% of the observations are males. And let's see, D says, what is the average family income? So if we look at family income, which is the 6th one down, the mean is 53.4. So that means since this is already measured in thousands of dollars, the average income is $53,400 and change. Okay, so we'll do more with summarize in question 6 and a little bit further on. So question 6 says, what is the median family income? Because right here we're given the mean, but we're not given the median using the regular summarize command. But you can also add an option on to the summarize command to get the median. So one way to do it is to type sum, and we're just going to look at family income. So summarize famint, comma, D. D stands for detail. And now we're given family income broken down by percentiles. So if you look in the middle where it says 50th percentile, that's the median. And so the median in this case is $45,000 or $45,000. And then it gives you more information. It gives you, of course, the first percentile all the way to the 99th percentile. So if you're in the 99th percentile, you're earning $175,000. It also tells you the smallest and the largest, which ranges from 5 to 250, which we saw in the regular summarize command. Okay. We're going to come back to summarize in a little bit, but let's move on. Question 7. Question 7 is about the tabulate command. And you can also use tab for short, but tabulate gives you a frequency distribution of any variable you're interested in. So we're going to do it for family income. So tabulate famint, enter. And now we see a breakdown. So this is giving us all the values for family income. So our family income values are actually rounded to the nearest, well, to the nearest 5,000. So we have 5,000, 15,000, 25,000, and so on. The frequency column tells us how many households fall or have that level of family income. So 15 households have $5,000. And that and the percent is saying that those 15 households make up 2.27% of the total. And then the last column is a cumulative percentage. So if you look at, for example, the next level of $15,000, there are 56 households who have $15,000 income. That makes up 8.48% of the total households. But then the cumulative percent tells us it's just adding up. It's a running total of the percent column. So the 10.76 tells us that 10.76% of households have $15,000 or less family income. Okay, does that make sense? Okay, okay, good. All right, so question 8 is how to create a new variable. So question 8, to create a new variable, the generic way to do it is to use the generate command. So we're going to use generate, create a new variable called per capita income. That's going to be equal to our family income variable divided by the household size, because the household size is just the number of family members in that household. So you type gen. Gen, G-E-N, is short for generate. You could type out generate if you want. Followed by the name that you want to give the variable. So I'm going to call it per cap inc. Then you hit equal. You don't need a space, but I'm just in a habit of putting spaces. So gen per cap inc equal. Now this is where you have to tell Stata what is equal to. And I already told you it's equal to fam inc divided is / household size, our existing variable, which is HH size. And that's it. Then you press enter. Now you see it doesn't do anything, at least that you can see. It did generate the new variable, but nothing pops up in the results window, which is the main window. But if you scroll down on the right-hand side in the variable window, you will see your new variable there, per cap inc. So if you don't get an error message, that means everything's fine and your new variable is created. So we can summarize it just to make sure, it's there, see what it looks like. So sum per cap inc. So there it is. The average per capita income is over $22,000. All right, so question 9. Says how many interviewees had a family income of greater than 50,000? Okay, so the quickest way to do this is to use what's called the count command. The count command literally counts what you tell Stata to count. So in this case, we want to count the number of observations if fam inc is greater than 50, because we're looking at 50,000. So you would simply say count if fam inc greater than 50. And then hit enter. So 286 households have a family income of greater than 50,000. All right, another way you could have done that, which would not the most efficient way, but it's still only one command. You can actually use the summarize command with an if statement. So pretty much any command in Stata that we're going to be using can be used in combination with an if statement, right? That if statement says only look at this subset of the data and do this, whatever I'm asking you to do, in this case count, for that particular subset of the data, meaning only households who have more than 50,000. So you could have said sum, and I'm going to say sum fam inc if fam inc is greater than 50. And then it would tell you more than you want to know. It's going to tell you I have 286 observations among households who have a family income of greater than 50,000. The average is almost $83,000, and it gives you the min and max and standard deviation. Okay, so we'll practice more summarizing in question 11. Question 10 asks us to do a scatter plot. I do like Tableau better for graphs, and I know that that both of you haven't used Tableau yet, correct?
Correct.
But
Okay.
I'm about to use it in 4 other classes.
Oh, you are? Wow, that's a lot of classes. What
Yeah.
departments are those in?
There's an accounting class, accounting information systems. Then there's an NC class. Then
Okay.
there's our class. Then this class.
Okay. So what I'm gonna do in this class is I am gonna go over some Tableau. It's gonna be an extension of what I did in 3318, which was very basic. I only did, I know Brady, since you weren't there, I only did one class period on Tableau and posted those materials in Blackboard. I would just recommend that you watch the videos that I linked to um, in that folder, and you should be fine. I did also post an exercise if you want to play around with it in a data set, and I can help you with that too if you need help after you look at the videos.
Need a specific computer for that, or can you do that on any computer?
Oh, Tableau is totally free for students, so you can download it yourself onto any computer. It is also installed in our classroom. So that is one nice thing about it. And in this class, I'm just going to do a little extension of what I did in the previous class and show you a few more slightly more advanced things. We're not going to spend a ton of time on it, but I do like doing my graphs in Tableau. It's just, I don't know, I find it easy to work with, especially if I'm making quite a few graphs. And it does some really cool stuff besides just make graphs, which I'm going to try to show you guys later on. Okay, so I am going to do the scatter plot though. I'll show you what the Stata graphs look like. So question 10 is scatter command. So it's going to make a scatter plot, and it says, let's plot the relationship between years of education and family income. We're going to put family income on the y-axis. So whichever one you want on the y-axis, you would enter first. So I'm going to put scatter fam inc and educ for education. Hit enter, and it's going to take a second while it's graphing and it pops up. So there's your scatter plot. Now this does not automatically appear in your log file. So if you want to save this, for example, and insert it into your Word document log file later, just go to File, Save As, and save it on your computer. Or it'll save it as a GPH file. Or you can literally just right-click, copy, and paste it right now into a Word document. So either one. And then when you're done with it, just close out of it.
Let's save as an image.
No, it saves as a GPH file, which you have to then open in Stata later. So if you want to save it as an image, I use my little clip it tool. I use it's called Jing, but use any clipping tool and you can save it as an image.
No, I meant when you copy it.
Oh yeah, like okay, so if I copy, I'm gonna do it right now. Copy, let me bring up a Word document and I'll do it. I have way too much stuff open, by the way. Let me just create a new Word document. There, it looks like that. So I think it's an image now. Save it as
Yeah,
picture.
it's
So
an
you can,
image.
yeah, so you can just save it as a picture. There you go. Okay. So going back, 1 second. There we go. All right, so question 11 is just more practice with summarize. So it says, find the minimum family income among interviewees with the maximum years of education in the sample. So we already know the max years of education is 20, but if you forgot, you can just type some education. Oh, and it tells you, okay, the max is 20. And among those with 20 years of education, I want to know what's the minimum family income. So I'm just going to summarize family income for the subset of these high education people. So I'm going to do sum fam inc, and use my if statement, and I want to say if education is equal to 20. Now, the one syntax rule that is might be hard to remember at first in Stata is that when you have an if statement and you want to put an equal sign after the if statement, you have to put a double equal sign. If you don't do it, it'll give you an error message. I'll show you that in a second. So sum fam inc if education double equal 20. And so there we see that we have 11 people who have an education of equal to 20. And then the average income is over 56,000. The min is 5 and the max is 175,000. My question was about the min, which would be 5,000, but we're of course getting the min, max, and the average. Okay, so if you don't put a double equal, let's see, it'll give you a message. So sum fam inc if educ equal 20. It just says invalid syntax. So that's what an error message will look like. It'll just give you depending on what the error is, it'll say something in red. And then you have to go back and figure out what you did wrong. Okay, the rest of 11 says find the max family income among interviewees with the minimum years of education. So now I'm going to summarize fam inc if educ double equal 8, because that's the minimum value of education. And now I see that I only have 2 people in my sample that have 8 years of education, and their income ranges from 5,000 to 15,000. Okay. So the rest of 11 says, for fun, we could try this another way, just to familiarize ourselves with a couple of other commands, those commands being the sort command and the list command. So what we could do is we could sort our data by education level and by income level. So I'm going to type sort. So if you just type sort education, it's going to sort all of your observations by education level. So now, I mean, you don't see anything. It actually did sort. And in order to confirm that, there's a few things you can do. One of them, you can now go look at your data. So we could go up to data, data editor, and browse. And you can see the education variable is the second column. And you can glance at it and tell that it's now sorted by education level, going from 8 to 9 to 10 and so on. Now I'm going to sort it by education, but within education, I'm going to sort it by family income. So sort educ fam inc. And now we can go back to data, data editor, browse. And education is still the second one. Family income is, 6 or 7 columns over. But you can see that the 2 people who have education of 8, the family income goes from 5 to 15. The 3 people that have an education of 9, the family income is now ordered from 15 to 25, and so on, all the way down. So why do I do this? Well, part of it was to show you the sort command. But the other thing you can do once you've sorted is you can use the list command to look at individual observations without having to open the data editor. So, for example, I could type list family income. So show me family income if, say, education double equal 8, the minimum value. It's literally going to show me the values for the 2 people, the values of family income for the 2 people who have education of 8. Or we could say list family income if educ double equal 20. And then it's going to show me, I think it's 11, the 11 people who have an education of 20, that's going to list all their family income values. Now, you can also list more than one variable. So if we wanted to look at family income and say male to see how many of them are male, if education equals 20, we could do that too. As many, you can look at as many as you want to. So there we can see that of those who have an education of 20, 2 of them are male. The other thing you could do with list is, let's just sort for fun. Let's sort by family income, but nothing else. So now we have everything ordered from lowest to highest family income. Let's just say you wanted to know, okay, what's the smallest value of family income? You could type list in 1. That will show you, that's actually going to show you for the first observation all the values for the different variables, because I didn't specify which variable to look at. You could say list fam inc in 1. That's going to give you the first person's family income after you've sorted by family income. So these are just some things to play around with. If you wanted to look at the first 10 observations of family income, you could type list family income in 1/10. Now it's going to list the first 10 observations of family income after you've sorted by family income. Okay, any questions? No? All right. So let's see, number 12. Number 12 is a table. I don't, I'll go through that one. I don't use tables that much in Stata. I probably should use them more. I've gotten into this habit where I use the summarize command a lot and then I make my tables in Excel. But let's just make a table for fun. This could come in handy at some point. Okay, so I'm giving you the command. I don't have it in this document, but I'm going to give you the command for this table. Otherwise, it would take, I think it would take forever to actually figure it out since you haven't used the table command before. So we're going to type table, and then I'm going to follow it with educ. So what we're doing here is it says we want to know the average amount of regular and organic apples that would be purchased, as well as the average prices quoted by education level. So I'm going to do a table by education level. So table educ, comma, and then I'm going to type C. That's going to stand for cells, open parentheses. I'm now telling Stata what to put in all the cells of the table. I want it to put the mean of eco-pounds. So I'm going to put mean space eco-pounds. I want it to put the mean eco-price. So mean space eco-price. The mean of the regular pounds. And then the mean regular price, close parentheses. That's it. Hit enter, and you have a table with education on the left-hand side and then all the averages following that. And then the mean eco price would be the average price that was given to people of that education level. The prices were basically chosen randomly, and then they told the interviewer how many pounds they would buy. Okay, so 13. Question 13 is basically more practice with summarize. It says, summarize eco-pounds and regular pounds for individuals with a family income greater than 50. So I'm going to sum eco-pounds, regular pounds, if fam inc is greater than 50. All right, we already know that's 286 households. My question says, oh, also do it for individuals with a family income of less than 30. So I'm going to go over to the review window on the left side and click at the bottom on my last command. And I'm going to change the greater than 50 to less than 30. Enter. And so now we're basically looking at higher income individual over 50,000, lower income families or individuals at less than 30,000. And you can just tell that if you look at the eco pounds, the average eco pounds versus regular pounds, the organic or eco pounds are higher for the higher income people than the regular pounds, and then the opposite is true for the low income families. Okay, 14 is finally a regression. So question 14 says regress eco pounds on eco price and regular price. So we're basically estimating a demand equation. So the command regress, but you can type REG as the abbreviation, followed by your Y variable, which is eco pounds, the quantity, followed by the X variables, which in our case are the price variables. And I'm gonna, I could add in family income if I want. We can add in whatever, we could add in obviously whatever we think affects eco pounds. So hit enter, and there's your output. So if you look at the output, in the top right, we have the number of observations. We have an R squared in the middle there, which is very low, 0.038, and an R bar or adjusted R squared, which I talked about in 3318. I'm sure if you talked about that. I don't know, did you talk about that in your class, Brady? It's called R bar or adjusted R squared?
I believe so.
Okay. Well, anyway, it's similar to R squared, except the main difference is that R squared will always increase when you add another variable to your model, and the adjusted R squared does not always increase. So it's,
yeah, we talked about that then.
Okay, yeah. So it's basically weighing the costs and benefits of adding another variable to your model. All right. So on the left at the top here is going to be your well, at the bottom where it says SS or SS column and total, that's your what we call the total sum of squares, also called the explained variation. And then it says residual, that's your unexplained sum of squares, also known as the sum of squared residuals. And we talked, well, you weren't there for that, but Brady, but Aman, you were there for that. We talked about how the sum of squared residuals is what the OLS process is trying to minimize. And then we have the model sum of squares, also known as the explained variation. And the important stuff at the bottom here, we have the variable names. So the Y variable is eco pounds. Then it lists all the X variables. And then the last thing it says is underscore CONS. That's where it's going to give us the intercept, the beta 0 hat. So the coefficient column is the beta hats. So this is the beta 1 hat, beta 2 hat, beta 3 hat, followed by the beta 0 hat at the bottom, the intercept. And then it's going to give us standard error, t ratio, p-value, and confidence interval, which I know that Amani might not know what all of that is yet, but we will get to that.
To be honest, I will need to touch up on my statistics a little bit.
Well, that's okay. I'm going to go over it all in class too. But you know,
okay.
the part what you need to know for our class.
Okay.
So I mean, I rely a lot on p-values when we talk about statistical significance, and so you know, I'm going to spend a lot of time in class talking about that. But for now, let's just look at the coefficients, because really that's what tells us the relationship between these X variables and eco pounds. So because this first coefficient, eco price coefficient, a negative 2.9, since that's negative, that's saying that there's an inverse relationship, right, between eco price and eco pounds. So the way I think of it is when eco price goes up, eco pounds goes down, which makes sense because that's the law of demand. If the price of organic apples goes up, the quantity purchased should go down. If we look at the next coefficient, the 3.03, that's saying that's a positive. So it's saying that the price of regular apples and the quantity of eco apples moves together. So if regular price goes up, so the price of regular apples increases, then people are going to actually buy more organic apples because the kinds of apples, that's telling us the apples are substitutes, right? The regular apples and the organic. If the price of regular apples goes up, I'm going to substitute away from regular apples and I'm going to buy more organic apples. And family income is positive, so that makes sense because as income goes up, we would expect people to buy more organic apples. Okay, so that's how to do a regression. And you can also add an if statement to a regression. So if you just wanted to do this regression, which we can do quickly for a certain subset of the population, let's just do, actually I'm going to click on my last command in the review window. Let's just do it for FAMINC greater than 50,000. So now it's only going to do that regression for those 286 people. So we're going to get slightly different coefficients. And now we can do it for, let's say, I'm going to replace greater than 50 with less than 30. So now I'm doing it for the 171 lower income families that make less than 30,000. And you can see, again, we're going to get slightly different coefficients. Okay, so you can use if statements. And then a couple more things. Number 15, question 15. That's on the last page of the warm-up document. So this is the display command. I just wanted to introduce you to the display command. It's actually pretty straightforward. The display command tells Stata to act like a calculator. So you could literally type display 2 plus 2. It'll give you 4. So it's just a way to do calculations. I'm going to do a simple regression quick because I'm going to use the display command following the regression to show you some things you can do. So I'm going to do a very simple regression of eco pounds on eco price. I could use a lot the other regressions too, but with more variables, this will take more time. So I'm going to do just one X variable. Okay, so here's my results. Let's suppose I wanted to predict the number of eco pounds purchased when the price of organic apples is, I don't know, some level. I'm going to plug it in. Let's say we want to, let me look at what the mean value of eco price is. Let's see, the mean value of eco price is, I found that way back. The mean value of eco price is about 1.08. So let's say I want to know what's the predicted eco pounds purchased at the mean value of eco price. I can display, and now I'm going to put beta hat 0, which is about 2.4, minus, I have eco price coefficient of about 0.845, and now I'm going to multiply that by the average price of organic apples, which is 1.08. Now in Stata, when you want to multiply, you put an asterisk. So I have 2.4, my beta hat 0, minus 0.845 times 1.08.
Isn't it gonna multiply first instead of subtracting?
Well, it's going to follow the rules of multiplication and subtraction. It's going to multiply those two things first and then do the subtraction.
Okay, okay.
But if you don't believe it, you can always put a parentheses around it.
No, I thought we were aiming at getting them to subtract first.
Subtract what? The
2.4, yeah.
Well, we want to subtract from the 2.4 the whole thing of 0.845
Okay.
times 1.08. Yeah.
Okay.
And then that's the answer is 1.49. So that's the predicted number of eco-pounds at a price of 1.08. So you can use display for that, but you can use it for any calculation you want. And the other thing that I have in the handout here is some notation that Stata uses. Instead of actually typing out the 2.388, you can actually use Stata's notation for constant. And this might be hard to remember, so you don't have to worry about it. But if you happen to remember it, underscore little b, bracket, underscore cons. What this does is it takes the last regression you ran, and this is the notation for the intercept. So if you type this, it's actually going to pull the 2.388 blah, 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 and use that in the calculation. And then I could put plus underscore b bracket eco price bracket, and I'm going to multiply it times the 1.08. So that underscore b bracket eco price is going to pull the last value of the eco price coefficient, which is the negative 0.845. So I'm literally doing the same calculation I just did. I'm just, instead of actually typing in the numbers, I'm using notation from Stata that says take the values from the last regression I ran and plug them in for me. So we'll get the same answer except for rounding error. Okay. But you don't have to use those if you don't want to. And then the last thing I want to show you is the predict command. So predict command is kind of a special command that we use to calculate some special variables. So specifically, we're going to use predict to calculate the fitted values, also known as y hat, and the residuals, also known as u hat. So all you have to do, if let's say you want to calculate the fitted values for every observation in your data set. And what does that mean? That just means I'm taking each person's X value, and this each person's, say, eco price, and I'm going to plug that in, and I'm going to get their predicted eco pounds. So after you run a regression and you want to get the fitted values, you literally just type predict and then name it. So I'm going to call it y hat. So the predict part is the important command. The y hat is what I'm naming the fitted values. You could call them fitted. You could call them whatever you want. So that's all I have to do. And Stata tells me, I just calculated your fitted values for you. So nothing happens except you come over to your variable window and you see there's a new variable there, and it's already named fitted value because the predict command is special and it will automatically create fitted values if you don't tell it otherwise. So we could look, if we go to data editor, and browse, and we scroll to the end, we should see our new variable. So there's y hat for every single observation, which means that is the predicted eco pounds given each person's eco price. Okay, the other thing we can do with predict is get our residuals. So I'm going to type predict, I'm going to call it u hat. And remember, u hat is the difference between y and y hat. That's the actual y variable minus the fitted value y hat, the predicted y variable. Now, predict u hat, comma, residuals. We're telling it to calculate the residuals. And that's it. Then we go over to our variable window, scroll down, we see we have our residuals. And you can open your data and look at them too.
So are all these variables being added to apple.dta, or are we going to get a chance to save another copy of that data with all the new variables added?
Yes, they are being added, and yes, in order to keep them there, you would go to File, Save As. So File, Save As, and then you would save the new data set somewhere. You can name it something else. Correct. The original is always going to be there on Blackboard for you to refer to. So you can save your new one to your hard drive.
Okay.
Yep. So this is different than the log file. You have the data set and then the log file. Saving the data set is different than the log file. That's just, the data. Okay. All right, so that's basically all I want to show you today. Do you guys have any specific questions before I am going to show you how to open the log file in Microsoft Word, but before that, do you have anything else that you are curious about?
I had a question about what was the difference between a single equal to and a double equal to?
Oh, you
Is it
only
just
have
like comparing and assigning?
it's just notation. So Stata requires a double equal after an if statement or as
Okay,
part
so
of an if statement. Yeah.
comparing is double equal to.
What do you mean comparing?
Like if you're comparing, let's say x double equal to, so we're asking it to see if x is equal to 20, then do this. But if we do a single equal to, then it's assigning, and then x
Okay.
becomes 20. That's how programming stuff goes.
Uh, okay, gotcha.
Yeah,
Yeah. See, I'm not really a programmer, so I don't know all that
yeah,
terminology. But yeah, if that works for you, go for it.
yeah,
My programming knowledge is limited to Stata and SAS, and that's about it. Okay.
Oh, I was reading like a syllabus for this class, and I
Mhm.
was under the impression we were gonna do stuff with R.
Oh, yes. I did not add it this semester.
Oh,
Sorry.
that's fine.
I apologize. It was in the description because it's giving, like, in the future, if, it's giving leeway to whoever teaches it to use whatever languages they want, basically, but they don't have to use all of the languages.
That's fine. I was just
Sorry.
curious.
Yeah. I know that, and I might add that in the future, but I didn't want to do too much this first semester that I'm teaching it. However, I know that, like, for example, all the master students get exposure to all the different languages, including R.
Yeah, it's R or Python and data analytics, and I
Oh,
was just
okay.
curious.
Yeah.
Yeah,
I know Python was popular. I wasn't sure. I know R. So, I mean, a lot of econometricians use R. It's somewhat popular. Especially with people who like programming, but I don't know. I mean, I find it's free, right? That's always a good thing. Um,
yeah, most of the languages are
okay.
anyway. So
Of course, this is not, but
yeah,
I find it to be like really user friendly. So for
yeah,
me,
I
like
would,
it's worth it.
unless we're using an IDE, it's not really friendly programming languages.
Yeah, I gotcha. Um, so anyway, other questions before I show you how to open the log file?
No?
No. So, I mean, these are just some basic commands, but we're really only going to be using basic commands. Um, you can do a lot with these basic commands. And for example, when we work on the project and we're doing our descriptive statistics, we're going to be using a lot of summarize commands with if statements. We might make a table or two in Stata. Sometimes if I don't make my table in Stata, I'll just use the summarize commands and then put stuff into Excel, copy and paste it. I will show you later how to use Stata to make tables for your regression. You can do that directly in Stata. Um, and I will show you what's called the do file editor, which lets you, carry out batch commands quickly instead of having, um, to enter one by one. You can just enter it all in, a little text document and write commands quickly all together. So I'm going to show everyone how to do that at the same time. So I'll show you a few things that will help with being more efficient. But when we do the project, it's going to be lots of summarize commands, maybe some tables. Then when we do the regressions, we're going to use regress commands. We're gonna use generate commands to create new variables. And the other thing I can show you real quick that comes to mind that I did show my 3318 command is how 3318 class is how to create a dummy variable quickly. It is a generate command, but there's some syntax that makes it more efficient. So let me do that real quick, and then I'll show you the log file. Okay, let me see, what dummy variable do I want to create? Let's take the education variable. So we know the education variable goes from 8 to 20. So I might want to create categories for my education. So I might want to say, oh, I want to put you in a category less than a high school degree, then greater than a high school degree. So I might want to put you in those 3 categories. So I'm going to create a variable for less than a high school degree. I'm going to assume that if you have less than 12 years of education, that you have less than a high school degree. So I'm going to create a dummy variable. So I'm going to say generate. I'm going to show you 2 ways to do it. Generate, just going to call it SHS for high school. Equal. So education, if, hold on, sorry, I'm doing it the quick way. I want to show you the long way first. Okay, the long way is generate less high school, set it equal to 1 if education is less than 12. So that's going to be anyone who has 8, 9, 10, or 11 years of education, since education starts at 8. So generate less high school equal 1 if education is less than 12. All right. So now what does it say? It says, okay, I created that variable, but I have missing values. And the reason it has missing values is because, well, we can look at the data, editor, browse. So there's my new variable called less high school at the end. And you can see the dots. The dots indicate missing data. The 1 is everywhere that person has 8, 9, 10, 11 years of education. So it put a missing value anywhere the person had 12 or more years of education, because all I told it to do was to put a 1 if you had less than 12. This is not a dummy variable, because to be a dummy variable, I need it to be 1 or 0. So I want it to be 0 everywhere that person has more than 11 years of education. So what I need to do to fix that is I need to say replace, that's a command, replace less high school equal 0 if education is greater than or equal to 12. So now I'm going to put a 0 for all the other people. And now I have a dummy variable. So I can go back, and you can see it made 640 changes to replace those missing values. So if I go back to my browser, now I have a dummy variable that's all 0s and 1s. That's equal to 1 if that person has less than 12. It's equal to 0 if they have more.
Could you do this with an else statement?
What's an else statement?
Like if this, do this, else do this, instead of doing
Oh,
like 2 different commands.
else. Yes,
Yeah.
yes. In Stata, you can do it in 1 command, but it's not. We don't call it. It's not an else statement. I'll show you. I'm gonna do it right now. Okay. I'm gonna drop. If you want to get rid of a variable, like say you created it incorrectly, just say drop less high school. I'm gonna get rid of it. I'm gonna create it again, the more efficient way. Gen less high school equal edu less than 12. So what this does is it says put a 1 everywhere this is true, meaning everywhere education is less than 12. Put a 0 everywhere else. And that's it. That's the more efficient way of doing it. So you can
Okay.
go back. Yeah, that's the state is, I guess, equivalent of an else statement. Go back to your data. There you go. So now you have the dummy variable in one command. So I was just showing you the long way first because I mean I think for people who don't know anything about programming, it makes more intuitive sense to do it that way first. But once you get the hang of it, it becomes much more efficient to just use the one command. So we could also generate a high school dummy variable. So if you have a high school degree, generate high school equal educ double equal 12. So it's saying put a 1 if education is equal to 12, put a 0 everywhere else. And then we could do generate greater than high school. I'll just call it greater high school equals education greater than 12. So now it'll put a 1 for everyone else above 12 and a 0 if it's not. So now you have three categories: less high school, greater high school. So if we summarize, less high school, greater high school, and we look at the averages, we can see that 3% have less than a high school education, 25.6% have a high school, and 71.4% have greater than a high school education, the way we've defined that. Okay, does that make sense?
Mm-hmm.
Okay. So I think that's it for now. I mean, I've showed you most of everything I showed them in 3318. If I think of something else in class, I'll make sure and point it out. But these are really most of the commands that we used, probably like 90%, if not more, that we used in 3318. So what I'm going to do is show you how to open the log file. If you forget to close your log file, it's not a big deal because Stata will close it automatically if you close down the program. So if you want to save your data set, you should go to File, Save As, save it to your hard drive. I'm not going to save it right now, but you can do that. And then go to File, Log, and Close. And it's going to tell you, okay, the log is closed. Now, again, it will do that automatically when you shut down Stata if you forget to do it. So I'm just going to go into Word, open Microsoft Word, and then go to where my log file is and open that. So let me pull up Word. So I'm going to go File, Open, and go to my econometrics folder. And I'm going to choose where it says all Word documents. I'm going to choose all documents because right now it's not a Word doc, it's a log file, which is a text file. So I'm going to go to all files, otherwise you won't be able to see it. And I'm going to look for it. So here it is, warmup 2019.log. Click on it. And I don't know why it's asking me that because it normally doesn't. There it is. Okay, so I just chose plain text. And this is my log file. So it just has a record of everything I did, all my commands and all the output. And one recommendation I have, if you look down here at the regression, it's actually wrapping. Just in order to fix the wrapping of the text, you can just either make your text smaller or make your margins bigger. I usually just select all and then choose font size 9, and that will take care of the problem. So now if you go back to where your regressions are, they don't wrap and they look much prettier. And then you just save this as a Word doc, and you can make edits to it, get rid of mistakes, clean things up, whatever you want to do. And so you'll just have to, so in 3318, I make you guys bring log files to the quizzes, but in 4318, you'll just have to turn them in with the homework. So that's it. So any questions? No? Okay, so what do you think of it? Brady, what do you think of Stata?
I think it'll be fine.
Okay, I'm just curious because I know you used Excel in 3318, and I find that, I know you can do it all in it. Well, not all of it, but most of what we do I do in 3318 in Excel, but it's kind of clunky, I find. So I was just curious if you had any, comparisons, but maybe as you use it more, you'll have more.
This is very similar to SQL.
Oh, it is. Okay.
Yeah, it's the format of the syntax of all the commands is very similar.
Okay.
And the commands themselves are pretty similar, like drop, select. I don't think we had a select, but we had a drop. No. That was very similar.
Yeah. Okay. All right, cool. Well, that's it. It's I like it because it's user friendly for me anyway, and it does everything I need to do. And like I said, it was at least I said in one of my classes, it was designed by economists for economists, but it has become quite popular, so a lot more than just economists use it now. But yeah, so it does everything I need to do, and it's gotten quite a bit more powerful over the years. So I use many millions of observations without an issue. All right, so I guess if that's it, I will let you guys go, and I will be posting some slides tonight. I'll email you when I post slides that I'll be using tomorrow in class.
All right. Well, thank you.
Thank you. Thank you.
Okay, you're welcome. I'll talk to you later.
Later.
Bye-bye.